Hello, welcome. Another episode, question number 9 on WASSCE 2024 May-June edition, written by Nigerian. So we are having this one on main section 1. The diameter of a circle with a center O is given as 26 centimeter. So if a chord PQ is drawn such that it is 5 centimeters from O to the center of the chord, we have to calculate, correct to the nearest whole number, the angle POQ, then the area of the minor segment, which is formed by the PQ. So this is our circle. The center is O. We want to draw a chord. Okay, let's draw a chord. If this is the chord, and that is going to be our PQ, then the chord is such a way that it is 5 centimeters from the center, and it is meeting the PQ at the middle, meaning it divides the PQ into 2. Then if I join this side, obviously that will give me the radius, right? If it is forming perpendicular to the base, then it will be right angle. This is the radius, but we have been given the diameter from here all the way to the other side as 26, meaning half of that will give us 13. 13. So this is what we have. Now, the first question is to calculate the angle POQ, meaning if we extend this line out there, which is also a radius, that line is also a radius. So if we are looking for, if this line is perpendicular, dividing this into 2, it divides the angle at the center also into 2. So if I know one of the angle multiplied by 2 will give me angle POQ. So I'll focus on the angle here as alpha. If that is the case, I also know this side as 5 centimeter. Looking at that, so I can say from the triangle, let's label here PQR. Triangle POR, this is the angle facing here as opposite, hypotenuse, adjacent. So we are making use of the, let's say we have so ka tua, right? We don't need the opposite. So we cross out all that contain O. So we left with ka, meaning we need cos of the alpha. The angle alpha equals to the adjacent side, which will be 5, divided by the hypotenuse side, which will be 13. But we are looking for the angle. So we have alpha equals to the cos inverse of 5 on 13. So alpha will be giving us 67.38 in degree. But let's hold on to that. That is not what we are looking for in all. We are looking for the angle at the center. That angle which we are looking for is twice of that. So the angle POQ equals to, let's say, theta equals to 2 times what? Alpha. If I multiply that angle by 2, give me the double of that, meaning 2 will multiply 67.38 to see what that value will be. We are going to have 134.76, but we are looking for nearest whole number. So I can approximate this to become 135 degrees. So the angle that we are asked to find for the first one is going to be 135 degrees. All right. Going to the second part, we are asked to find the minor segment. We have PQ with this arc is the minor segment. PQ with this longer arc is the major segment. So all that we are looking for is this segment. And there is no direct formula in finding the segment here. So we first find the area of the sector, the complete sector, minus the area of the triangle formed on top of it. So area of the sector minus the area of the triangle give us the area of the segment. I think I did tutorial on this. You can check it in the playlist under menstruation 1. So for B, I begin with the area of the sector first. So area of sector, we all know is theta over 360 times pi r squared, where theta in this case is the angle at the center, POQ. That is the theta we have there. So let's do substitution. What would that be? 134.78. I'm using the decimal part so that I will not truncate my answer. Divided by 360 times 22 out of 7 times the radius, going to be 13 squared. So let's put that on our calculator and see all together what the answer will be. So if you do that, you'll be having 198.85. Let's leave it 5 in there as are we using centimeter? Okay, so centimeter squared. We are not looking for the area of the sector, so let's leave that one there. The next is to find the area of the triangle above it. That's the next one. So the next thing is to find area of the triangle POQ. POQ. And this triangle is an isosceles. So the isosceles have the two sides given with the angle inclined. So I will not go for half base and height. Meaning, if I want to find the half base and height, I need also to know the length of the chord. I am not interested. So I will say that the area will be equals to half AB sine theta. And the theta is the angle formed at the center. So in this case, AB, meaning this side and this side, the two lines that combine together to produce the angle is the AB. So I only say that the A is R, the B is R, therefore R squared, when it is having an isosceles. Okay, let's follow with substitution. 2 times 13 times 13. The sign of the angle, I'll be using 134.76. I'll still use not the approximated one. So let's see what that will give us. And that will be giving us 60.000, and the area is still centimeter squared. So here we are now going to find area of minor sector segment will be equals to area of the sector minus area of triangle. And that is going to be area of the sector, 198.85 minus 60.00 for the triangle. And if you do that, you will be having 138.85. So therefore, the area of segment will be equals to, let's say, nearest whole number. So 139 centimeter square. Nearest whole number will give us 139. So in finding the area of a segment, you must take it as a sector minus the triangle. And if you want to use the half base times height, then it means you have to use the angle here, find here, times 2, give you the length, before you can use half base times the height. I'm sure we are together. Thanks for watching. Like, share, and comment. Bye bye.